A complete solution of class 10 mathematics under Board of Secondary Education Manipur. Solved, recorded and edited by Salam Meghasundar Singh, lecturer, Churchan Higher Secondary School, Imphal. 1.1 Introduction. We introduce a brief discussion of the integers, field properties of the real numbers and absolute values of the real numbers. Aikoina mafam asida integers sing real numbers sing field properties sing amasu real numbers sing absolute values sing maramda sandokna nainagani. Number theory is a branch of mathematics which deals with natural numbers and integers. Number theory haibasi natural numbers sing amasung integers sing maramda nainaba angkagi masa amani. 1.2 Arithmetic deals with numerical calculations involving only the basic operations of addition, subtraction, multiplication, division, and simple powers. Arithmetic haibasida masingi oiba calculation haibadi addition, subtraction, multiplication, division, amasung simple powers singi maramda nainagani. Mathematics is the queen of all sciences and arithmetic is the queen of mathematics. Angka haibasi science pumnamaki maharani ni aduga arithmetic haibasi mathematics ki maharani ni. Carl Friedrich Gauss, a German mathematician, amana harambani. Aikoina hana sukhang kare dividend is equal to divisor into quotient plus remainder. Yenagadaba haibasi yenariba amasung athungba anigi purinaba folda aremba hapsilaga phange. Chapter 1 Number System Euclid's Division Lemma. Euclid's Division Lemma statement yengsi let a and b be any two integers and b greater than 0. A amasung b asi karigumba integer anini mafam asida b asi 0 dagi sauba number integer oigadaban. Then there exists unique integers q and r such that a is equal to b into q plus r and r is lying between 0 and b, including 0 excluding b. A amasung b si karigoma integer anini b na 0 dagi sauba integer oigadabani adu oirabadi q amasung r haiba kaknaba integer ani laigani madu a asibu b ga q ga purinaraga r hapsin bagi mawongda phongdokpa loinana r asi 0 amasung b gi marakta laiba integer akaknaba integer ama oigadabani r na 0 oibadi yai b oibadi yadi. Note mafam asida piri statement asigi khangjinba yaba sing adudi in the above lemma q is quotient and r is remainder with respect to b. Mathaki lemma asida q asibuna atungba r asibuna aremba b gi yengnarubada kawi. This is also known as Euclid's division algorithm. Mathaki lemma asibu Euclid's division algorithm haina sukhangnagani. What amakak lemma haiba what amakak yauri. A lemma is a provable statement used in proving another statement. Lemma haibasi prove toba yaba statement amani masina atokpa statement ama prove toba decision nagani. An algorithm is a well-defined sequence of steps for solving a given problem. Algorithm ama haibasi apiba problem ama solve tobagi mathang manau nairaba steps singi sabul amani. Euclid's algorithm for finding ICF of two positive integers stepwise. Euclid's algorithm sizinaraga apiba positive integer anigi ICF puthokpagi mathang manau nairaba steps sing adudi. Number 1. Find the quotient and remainder of the division of the greater number by the smaller. Akhara sauba number aduda khara pikpa number yenbagi aremba athungba amaso aremba puthu. If the remainder is 0, then the divisor is the ICF. Aremba aduna 0 oirabadi yenarib aduna apiba number anidugi ICF haibadi highest common factor ni. Else take the previous remainder as the new divisor and the previous divisor as the new dividend. Arembadu 0 oidrabadi mamangi aremba aduna anauba yenariba ohello mamangi yenariba aduna anauba yenagadaba ohello. Find the quotient aduga atungbadu puto and continue the process till the remainder is 0. Aremba aduna 0 oidribak thong asi makha tana sathau. The last divisor is the required ICF. arembana 0 oiba matamda leiba yenariba aroiba yenariba aduna apiba positive integer anidugi ICF ni haribi step mari asi changani tangai phadana. The ICF of A and B is denoted by order pair A, B. First bracket ki manungda A, B iraga apiba number anisigi ICF ko khangnagani. Atopa mataba mafam asida khangnaroi. Textual questions. Text ki questions singa jodi every integer is of the form twice q or twice q plus 1. Integer khuding mark twice q natraga twice q plus 1 ki form da thamba yai. Or thrice q plus 1 or thrice q minus 1 form ahum sigi manungda integer khudingmak form ahum sigi manungda ahum sida phongdokpa ngangbani 4q plus 1 or 4q plus 2 or 4q minus 1 every integer khudingmak 4 gi multiples or 4 gi multiple gi 1 more or 4 gi multiple gi 2 more or 4 gi multiple gi 1 less haiba form asi da thamba yai. Every square integer is of the form 4k or 4k plus 1 mafam asida k as atopa integer amani. Square oiba integer khudingmak 4k natraga 4k plus 1 na phongdokpa ngami. Every odd integer is of the form 4k plus 1 or 4k minus 1. Odd integer khudingmak 4k plus 1 natraga 4k minus 1 na phongdokpa yai. Mamangi 1 gi a da twice q plus 1 masisu odd integer gi form amani. One of every three consecutive integers is divisible by 3. Thangnaba integer ahungi manungda amadi 3 ni yenba yagani. Exercise 1.1. Using Euclid's algorithm, find the ICF of 1240 and 19I4. Ahanba Roman number 1 gi piriba number positive integer anisigi ICF putoksi. Akhara sauba number 194 asi 1984 asi 1240 na divide to the 1 chale remainder 744 oire. Hari basi karamna lakpage habadu rough work ama yengsi 1240 na yelasi kanada khara sauba number 1984 da kwasinda 1 chale adudi 1240 leirani subtract tawrabadi 4 leire 4 leire 7 leire makatana 1240 ni yenba yadrabanina 1240 si amuk new dividend uhelo remainder ni yelabadi 2 sapi adre 1 adudi 744 leirani masi amuk subtract tawrabadi 6 leire 9 leire 8 leire 4 leire makatana amuk yenba yadrabadi last divisor 744 asina new dividend uhelo 2 sapi adre 1 chatle 496 leirani subtract tawrabadi aikon 8 phange 4 leire 5 odi 2 leire masi makata ni yenba yadre 496 asida mu yelabadi 2 chale 496 phange remainder 0 ni masibu Euclid's algorithm da sum irase hanagi divisor 1240 asina new dividend ohelo remainder 744 asina new divisor gi phampam da thamo quotient 1 leirani remainder adu mafam asida 496 ore madu basum na thamsi hanagi divisor is a new dividend hanagi remainder as in a new divisor quotient ohele mafam asida remainder asi 496 sorry remainder asi 0 tadreba process asi sathagani 744 as in a new dividend ohelaga remainder 496 the new divisor ohelabadi quotient 1 remainder 248 madu asum no phongdo e amukso remainder si 0 tadreba phawba 496 as in a new dividend ohela remainder 248 as a new divisor ohelo quotient 2 chale remainder 0 ore 496 as Euclid's algorithm sisnaraga sono phongdo a divisor 248 into quotient 2 plus remainder 0 oba matamda oriba angang bane iriba divisor 248 asina apiba number ani asiga ICF ni hence the required ICF of the two given numbers is 24I. Asumna Roman number 2 su pangthokani. Piramiba number anisigi manungda khara pikpa 248 asina khara chawba number 504 the divide toro 2 sape adre 1 chatlo 348 lerani subtract toro badi 6 lere 5 already 5 lere 1 lere 156 3 4 3 4 8 chalabadi 2 chalani 2 chalabadi 12 lare manga ani tara tara mathoi lare ani mani ahum lare khaidok narabadi 6 3 lare 36 makha tani yen be yadre 156 asri yalabadi mari ahum train thoi ahum chale ahum tok train pa ahum ma pantara mari chalade mari hum train thoi mari chalase mari taruk kun mari khuta ani mari hum tan tara mari kaya lere khaidokna rabadi 2 1 lere yenbe yadrabanina 36 asi putaro trainthoi ahum kuntra taruk mafam asli remainder 0 ore masi Euclid's division algorithm siznaraga 3 4 8 asi remainder 156 ni yembada 2 chatlaga aremba 36 oigani aremba 36 asi hoji 0 oidri adona hanagi divisor 156 asina new dividend ohille aduga remainder 36 na divisor ohellabadi quotient 4 chatlani remainder 12 lare madubu table asida sunna utli remainder 12 ore hojik su 0 tadri divisor 36 asina new dividend ohelle remainder 12 asina divisor adudi yelabadi 3 chatlani remainder 0 ore mafam asida oriba divide last divisor 12 asina ICM ni hence the required ICF of the two given positive integers is 12. 1. Using Euclid's algorithm, find ICF of Roman number 3. Number anisigi ICF puto haibani Euclid's algorithm siznaraga 899 khara pikpa number asina khara chawba number 986 the divide torasi 1 chatle adudi 899 khaidokhrabadi 7 lerani 8 lere 87 lere 87 makha tani yenbe yadre 899 di yellow 1 chatle 87 lerani 2 khaido khro 9 yen makata ni yen be yadrabadi 87 last divisor do dividend ohale quotient da ahum chalabadi 87 lere matam asi remainder 0 ne masi wa sumna phongdokani 986 haiban number asi akhara people number 899 yen be the quotient da 1 lere remainder 87 ore remainder 0 oidri 899 asina new dividend ohelle remainder 87 ni divisor ohelle yenba matam da quotient da 0 puthare yadre quotient da 10 lerani quotient da 10 lere remainder 29 remainder 0 tadre phawu chathaga da 87 sina new dividend ohelle remainder 29 new divisor into 3 lere plus remainder 0 so yagi koina kari khange hence the required ICF of the two given positive integers is 29. For Roman number 4, we have Roman number 4 asisu khara pikpa number 1240 asina khara chawba number asi yensi 4216 ta yelabadi quotient da ahum chatle ahum 00 ahumari trainte ahumani taruk taret ahum mama ahum 6 lere 9 lere 8 lerabadi 4 lere sini divide to makata ne divide to we adrabadi 1240 sila o ani chalo ahum chalabadi ngam tra yadre ani chaladi taruk ani trainte mapan traipan trampan amari ni pan mapan subtract toro the 8 lere 4 lere 2 lere makata ne yambe yadre 496 the divide toro 2 chalabadi 2 chalabadi 496 lere remainder 0 masibo asumna irani 1 to 4 si new dividend ohele remainder 496 na divisor matam asida quotient 2 ore remainder 248 ore remainder 0 odri mafam asida su 496 na new dividend ohele 248 na divisor ohele quotient 2 lere remainder 0 oiba matam da laiba divisor 248 asina ICF ni hence the required ICF is 248. Question number 1. Using Euclid's algorithm, find the ICF of Roman number 5. Roman number 5. Number anisigi ICF putoksi. Aikun ahan ba maktada actual division je pangthokani khara pikpa number sina khara chawba number 10,605 shri yellow 2 satpa yabra 2 satpadi 2 saladi 2 satpa yai taruk ani train thoi manga ni tara tara ma thoi ani ni mari manga ani manga tara subtract toro 3 lere 9 lere 9 still lere 6 lere 0 93 leme 93 sina muk divide torasi खर चाव नंबर न्यू डिवाइजर हाने की डिवाइजर सी न्यू डिविडेंड to hello sini salary mapolo mapongan mapun taruk yang primary mapun manga nipu manga chalo manga tra manga mapun nipu taruk skaido krabadi 0 lere taruk lere matang 6 putaro 6 putarabadi mapun tarir humpunde mapun taruk chalani taruk trai pan mapun taruk yang primary manga खाइदोखरबदी तरुक निपान लेरनी तरुक लेरदी मरी लेरे 40 से 93 नमुक येलो 93 से पुतरो 2 नु चटलबदी 96 नि 1 चटलनी 48 लेरे सिदगी से खाइदोखरदी मंगा ओदी मरी 40 सिदा 45 नि येलोबदी 1 चलो 45 3 लेरे 3 असिना 45 तमुक येलोबदी 1 चलो 3 1 पुतरे मंगा तरा मंगा remainder 0 hariba asi Euclid's algorithm siznara sunni ithoni har chawa number this into this amo 5 to 5 6 asina dividend ohelo di remainder ne divisor quotient 56 lere remainder do 48 ore remainder 0 tadri 93 na amo dividend ohelo new dividend 40 ani yellow 1 chatle 45 1 chale 45 lere 48 sina amuk dividend lo 45 yellow 1 chale 3 lere 3 leme 45 ase amuk new dividend lo remainder 3 divided already 15 lere remainder 0 hence the required ICF is 3 for number 6 we have this number ani asi so amuk actual division pangtokani 9269 asina yellow Canada 10,005 sidi yelabadi 1 chatlani 9269 sidagi di taruk sa karo tarit odi ahum oradi tarit lare 9269 the chatlabadi 1 736 091 9 chalo tarit ahum kumato ani chatlani 72 lairani tarin taramari 7 putaro tarin taramari laire 7 putaro sidagi 3 lairani 5 or 4 lairani 7 3 6 1 chalo 1 chalo di 4 3 7 sigi 9 lairani 9 nama lairani 5 or 2 laire sinamo 4 3 7 de yelabadi 2 chalo yadre 1 chalani 299 subtract torabadi 8 lere 10 lere 3 lere 1 sigi 1 3 8 sina amuk yelani 299 da ani saladi pani trataruk omnitaruk taret aniyama ani kaidok narabadi 3 lere 2 lere 23 sina 1 3 8 yellow manga taruk taret taruk trai trai thoi taruk chalo taruk trai pan taruk ni trai thoi tarahundo lere masibo asumna aikoina sigi form sida tamani remainder na divisor 736 na new dividend remainder na divisor remainder 299 ore sinamu new dividend remainder na divisor remainder 138 ore 299 sina new dividend 138 na divisor 2 chatle 23 leme masibo mo 138 23 into 6 plus 0 hence the required ICF is last divisor, that is 23. Question number 2. So that the product of two consecutive integers is divisible by 2. Thangnaba integer ani ge product asi 2 na soidani yenbi yagani utlu haven. Let a and a plus 1 be two consecutive integers. Thangnaba integer ani du a amasung a plus 1 lokselle. Makoi ani ge product to 2 ni yenbi yai utkadabani. The integer a is of the form twice q or twice q plus 1 for some integer q. A haiba integer si atopa integer q haiba ama lauraga twice q natraga twice q plus 1 form the thamba yai masi textual questioning work out yaw krabani masi koni khongjing gadabani every integer singa si twice q natraga twice q plus 1 the phongdok pa yai habado. When a is twice q, then the product of a and a plus 1 A the twice q sinjalabadi we get this 2 into another into q into twice q plus 1 atopa integer amani adudi mabani gi product say 2 into another integer the phongdokpa ngamlabadi masi 2 ni yenba yai habdu tai which is divisible by 2. When a is twice q plus 1, then product of a and a plus 1 is a the twice q plus 1 loin sinjalasi asuna ani subadagi 2 kama log cross hilare q plus 1 into twice q plus 1 as the top integer amani 2 into another integer the phongdokpa yarabadi mabani gi product say 2 ni yamba yai habdu tai maram sidagini which is divisible by 2 harisi उइथोकपा याबा ए गी फॉर्म अनिमक्ता लोइनमक तुना यंबे यारे मरम असिगी खोना conclude आइबदी वरोइस पिबी यारे. Thus the product of any two consecutive integers is divisible by 2. Karigumba integer thangnaba integer ani gi purinabasi tuna yembe yagani habasi generalize tawba yare. Question number 3. So that the product of two consecutive even integers is divisible by I. Thangnaba even noiba integer ani gi product ase tuna yembe yahabas ani yembe yagani habasi ulu haban. Let a and a plus 2 be two consecutive even integers. Thangnaba even over integer ani do a amasu a plus 2 on a lowrani. Thangnaba integer ani do two difference like adabanina. The even integer a is of the form twice q where q is an integer. Even integer receive two. Even integer kuding maksi twice q mong the phongdok pa yai mafam asida q habasi a ga sanaba atop integer amani. The product of two consecutive integers is even. Thangnaba integer ani gi product ase even habadi 2 ni yembe yai habasi koi mamang na thengnakre. When a is twice q, then the product of a and a plus 2 a gi value the twice q bisilo manungda lebe a asi twice q bisilo 2 kama log thora abadi 4 into q plus 1 q plus 1 di matak statement asigi matung inadi asi 2 ni yembe yaramni even or di twice k the phongdok pa yarani twice k asi mafam asida q into q plus 1 where k is an integer k asamu integer da kare that is I k phange I k habasidi I na compulsory yembe yare marandi I k as integer ni which is divisible by I, hence proof. Question number 4. Prove that every integer is of the form 4q plus 1, 4q plus 2, 4q minus 1. Integer khudingmak form sing asida 4q natraga 4q plus 1, 4q plus 2 natraga 4q minus 1 form mari simanung amadi hekta thamba yagani haibani. Let a be any integer and a have any integer ama lowrasi. Taking b equal to 4 and applying Euclid's division lemma. Euclid's division lemma that divisor to 4 ohilasi. We get Euclid's division lemma ke matung inadi a is equal to 4q plus r, where r is lying between 0 to 4 including 0 excluding 4. Then r we have a value sing here r can take 0, 1, 2, 3. Mari signal r integers atopa numbers thus a is of the form mataki Euclid's division lemma si the algorithm si the yauri ba r si umagi oitukuya ba value sing matang piraga form mari asi phange but ahan ba form ahum simadi tahan gada ba form ore akon bagi si the further simplification is required. But 4q plus 3 have a say 3 as 4 minus 1 asuna phungdok pi ahan ba tam anistagi 4 kama lokthokrabadi 4 times of q plus 1 minus 1. Q plus 1 is always integer ni k have integer amana mau sindokasi 4k minus 1 phange 4q plus 3 as 4k minus 1 have the 4q minus 1 form the thamangame. Thus every integer a is of the form 4q plus 1 4q plus 2 or 4q minus 1 form mari sigi manunga amade hekta thamba ngangani habatu praman tawre. Number 5. So that the product of three consecutive integers is divisible by 6. Thangnaba integer ahum gi product ase 6 na yenba yagani utlu haibani. Let a plus 1 and a plus 2 be three consecutive integers. The product of any two consecutive integers is divisible by 2. Thangnaba integer ani gi product ti 2 ni yenba yai habasi koi hana khangkre. So a into a plus 1 into a plus 2 is divisible by 2. Why? A into a plus 1 is 2 ni yambe yai or a plus 1 into a plus 2 is 2 ni yambe yai. Also, we have learned that one of every three consecutive integers is divisible by 3. Thangnaba integer ahumgi manungda amadi 3 ni yemba yagani haibani. Hojik mathakta pihoriba integer ahum si thangnaba integer singni. So, a into a plus 1 into a plus 2 is divisible by 3. 3 ni yemba yare. But 2 and 3 are co-prime. 2 amasung 3 di co-prime ni haibadi makoi ani gi common factor 1 natana laite. So, a into a plus 1 into a plus 2 is divisible by 2 and 3. Makoi ani mani yenba yaba haibadi makoi ani ICF LCM 6 na yenba yarani. 6 na yenba yare. Hence, the product of any three consecutive integers is divisible by 6. Thangnaba integer ahum gi product asi 6 na soina yenba yagani haibado masana tajari. So that the square of an odd integer is of the form ik plus 1. Odd integer amagi square si ik plus 1 gi form da thamanga mi utlu haibani. Let a square be the square of an odd integer a. A square si odd integer a gi square ne. Load si. The odd integer a is of the form 4q plus 1 or 4q minus 1. Odd integer a asi 4q plus 1 natraga 4q minus 1 form da thambayai. When a is 4q plus 1, then a square whose value is 4q plus 1 whole square. By expanding, we get this. Ahan matam anidigi 4 8 kama log thokrabadi, we get this. Bracket manung asi amuk integer phange k na mau sindokre ik plus 1 tahan gadaba form adu tabangame. When a is 4q minus 1, 4q minus 1 over matamda a square value su phange asum expand tok thobadi bracket asisu k na sindokra atop integer amana ik plus 1 form da tabangame. Thus, the square of an odd integer is of the form ik plus 1. Odd integer amagi square si ik plus 1 gi form na thamangame atopa form na thamangamde. 7. If a is divisible by neither 2 nor 3, so that a square plus 1 is divisible by 24. A asi 2 amasung 3 animuni yemba yadaba masing oirabadi a square minus 1 asi 24 ni yemba yagani ullu haibani. It is given that a is not divisible by 2, so a can be put in the form of twice q plus 1 for some integer q. When a is twice q plus 1, then a square minus 1 whose value is this. Expanding and cancelling, we get 4 into q plus 1. That is q into q plus 1. The thangnaba integer ani product to 2 ni yambe yari twice k the phong to a, we get 8k phange. This is divisible by 8. Again, it is given that a is not divisible by 3. A as 3 ni yamba yadi haibani. A 3 ni yamba yadragadi a can be put in the form of thrice q plus 1 or thrice q plus 2 harib ani cd 3 ni yamba yadaba number singi form ni for some integer q. When a is thrice q plus 1, then a square minus 1 whose value is this. Expanding, we get or cancelling these 2 and 3 times of this. This is divisible by 3. C 3 ni yamba yare. When a is thrice q plus 2, then a square minus 1 whose value is obtained by giving a equal to thrice q plus 2, we have this cancelling and taking out 3, which is divisible by 3. 3 ni yamba yare. Formally makta 3 ni yamba yare. But 3 and 8 are co-prime. Mabani I save to 1. Hence, a square minus 1 is divisible by 3 into I, that is 24 ni yamba yare have the mandor. Question 8. So that any square number cannot be put in the form 4k plus 2 square or even number khudingma 4k plus 2 ki form thamangamde utlu haven. Let a square be a square number. A square is a square number. Amani, the integer a is of the form twice q or twice q plus 1 or not even ki form the thamangami a have c. When a is twice q, then a square whose value is 4q whole square, that is 4q square, that is 4k q square is atop integer ama phange. When a is twice q plus 1, then a square whose value is either twice q plus 1 sinjalo whole square di expand tawrasi, we get tahan batamani degi 4 kama log thokra 6 bracket 6 ken sindokari 4k plus 1. Hojik a square value is 4k natraga 4k plus 1 gi form da thamangami. 4k plus 2 की form द थम्बा ngamdi every integer say twice q not twice q plus 1 form ani si manung da amade hekta thamba ngamni haibani hariba a gi oitokpa yaba form ani si a square sinjama matam da phanga iba form singa si 4k natraga 4k plus 1 ne adu 4k plus 2 ki form da thamba ngamdre. Thus every square number is of the form 4k or 4k plus 1 form da thamba ngame, but hence every square number cannot be put in the form of 4k plus 2 4k plus 2 form da thamba ngamde. Question number 9. So that any square number is of the form thrice n or thrice n plus 1. Square number khudingmak thrice n natraga thrice n plus 1 form da thamba ngami habani. Let a square be a square number. The integer a is of the form thrice q plus 1 thrice q minus 1. A is the form ahum sigi manung da thamba ngami haba koi mamang da thengnakre. Mafam asidadi 3 ki multiples urabani na koine twice q natraga twice q plus 1 ki form da lawroroi a is. When a is thrice q, then a square whose value is 9q square. This is 3 into thrice q square. Thrice n is thrice q square. The thamboromasi atop integer money. When a is thrice q plus 1, then the value of a square is 3 into this plus 1. That is thrice n plus 1 brackets n have atop integer amana sindokro. When a is thrice q minus 1, then a square whose value is by expanding we get sizu integer amani madu n sindokro. Thrice n natraga thrice n plus 1 form ani sigi maung da thamba ngami. A asine au form ahum ji thamba matamda a square ki form asi thrice n natraga thrice n plus 1 ki form da thamba ngami. Dagi koina conclude to yare. Thus every square number is of the form thrice n or thrice n plus 1 atopa form da thamba ngamde. Hariba form ani si manung da amara thamba ngamba natana leite. Question number 10. So that one of three consecutive odd integers is a multiple of 3. Thangnaba odd integer ahungi manungda amadi 3 ge multiple oigani prove to haibani. Thangnaba odd integers ahungi manungda amadi 3 ge multiple oigani ulu haibani. Let a plus 2 and a plus 4 be 3 odd consecutive integers. Thangnaba odd integers ahumdu form asumna lawrasi. The odd integer a is of the form thrice q plus 1 or thrice q minus 1 where q is an integer. Odd integer is equal to twice q plus 1 की form amasu thengnakre aduba mafam asidadi koina a की form asi ahum sigi manungda amade ka thamanga me habisi logani and a multiple of 3 and question they arise torokunina. When a is thrice q, then a equal to thrice q, which is divisible by 3. When a is thrice q plus 1, then a plus 2, whose value is multiple of 3. When a is thrice q minus 1, then a plus 4, whose form is, we get 3 into q plus 1, which is divisible by 3. Our form of thus, one of three consecutive odd integers is a multiple of 3. Odd thangnaba odd integer ahungi manungda amadi 3 ge multiple oigani habido praman tore. Question number 11. So that the product of any three consecutive even integers is divisible by 48. Thangnaba integer ahungi product asi 40 ani yemba yagani ulu haibani. Let a plus 2 and a plus 4 be three consecutive even integers. The even integer a is of the form twice q where q is an integer. The product of three consecutive integers is divisible by 6. Masamasukoi hana khangnakre. Thangnaba integer ahungi product asi 6 ni yemba yahebama. When a is twice q, then the product of a plus 2 and a plus 4 whose value a da twice q sinjalabadi we get this 8 into 6k. Thangnaba integer ahungi product asi this 6k multiple ni 6 ni yemba yahab mathaki statement do lawraga sijinare 6k na putting to our that is 48k. Which is divisible by 48. Thus, the product of any three consecutive even integers is divisible by 48. Thanks for watching.